Welcome to your video for Tuesday, and in this video I'm actually going to be explaining the activity for today, Wednesday and Thursday. So we have the same aim and the same success criteria as I explained yesterday because we're continuing on the same topic as yesterday. So do you remember how we read Mr. Archimedes' bath and what happened with the water when all the animals hopped in it? Now I'm going to be continuing on and showing you.
So what happened when all those animals got into the bath?
The water was displaced.
And remember, displacement is when an object enters the water and pushes out the water to make room for itself.
It pushes out the water to make room for itself.
A volume of water that is equal to its own volume. So we're going to be doing an experiment.
So we're going to be doing an experiment.
See how these hockey balls,
and we're going to see how these hockey balls,
they push the water out to make room for itself.
They push the water out to make room for itself.
The water up the same amount of volume as this weighs.
The same amount of volume as this weighs.
If I got a
so
glass,
it doesn't matter what
and I put it into water, if the water that's going to be displaced
and I put it into water,
is the volume
the water
of the
going
object.
To be displaced
so if I put
is the volume of the object.
Marker
so if I put
water,
the
only amount of water that's going to be displaced,
the only amount of water that's going to be displaced is the volume of the object.
Just learned about what volume is.
Okay, so you've just learned about what volume is.
We've also talked about
you've learned about what capacity is, and we've also talked about displacement of water. So now we're going to do a little experiment, and I'm going to show you how different items, when they're put into water, can make the water displaced. Okay,
I've got my container here.
So that's what we're going to be doing today. I've got my container here. I'm going to fill with water.
This is going to make a very big mess in my kitchen.
This is going to make a very big mess in my kitchen.
So I filled my container.
Lucky, I've got a towel. So I filled my container.
I'll move the camera in a minute so you can see me. And I've got two hockey balls that are the same weight.
And I've got two hockey balls that are the same weight, the same size, exactly identical
into the water. I'm going to
drop my hockey balls into the water.
I'm going to get a marker level at where
and I'm going to mark the water level at where I filled it. So I'm going to go all the way along there.
So that is how much volume of water is in this container.
So that is how much volume of water is in this container. Now remember, the capacity is how much the container can hold. So the capacity of this container is actually all the way up to the top, because that's how much water it can hold. We could fill it all the way up,
but at the moment it's only sitting at about
full capacity. But at the moment it's only sitting at about half capacity because the volume of water is only up to that line, which is about half the container.
I want you to think.
So
what would happen if I just gently drop this ball?
What would happen if I just gently drop this ball into the
water's going
water?
To overflow?
Do you think
the
water's going to overflow?
Level is going to change?
Or do you think the water level is going to change?
Going to drop this one ball into the
Let's
water.
Have a look.
See if the
going to drop this one ball into the water. Let's see if the water changes. Let's see if the volume of the water changes.
Now if you can see that.
Now, if you can see
it's
that,
just come above.
It's just come above
with the marker. So the
level that we marked with the marker
has increased, hasn't
so
it?
The
it's volume
come above the
line.
Has increased, hasn't it? It's come above the line.
Hasn't changed though.
The capacity of the container hasn't changed though.
The volume
I can still fill the water all the way up. The volume has changed. The water has been displaced. It hasn't been emptied. It's just moved up a little because of the volume of the ball. So let's see how much do you think that the water will change if I add a second ball in?
Changed a little bit, it's only just above
the line. We know that it's only just changed a little bit, it's only just above the line. I wonder if it's going to
Let's have a look.
Move up even further. Let's have a look.
There we go, I've got two.
There we go, I've got two.
You can see here, the water has been displaced double the amount.
The water has been displaced double the amount from when I
take them out again.
Had no balls in there. So let's take them out again.
Yep, there we go. My water is back down to where I marked it.
Yep, there we go. My water is back down to where I marked it.
Let's see what happens if I add them at the same time.
Let's try that again.
Do you think
Let's see what happens if I add them at the same time. Do you think it's going to change?
Or do you think it'll be the exact
it
same?
gets pushed up?
There's no difference.
Or do you think it'll be the exact same? There's no difference from if I add one ball,
whereas if I just add
then two balls
both at one time, it's
whereas
exactly
if
the same.
I just add them
and there we go.
both at one time,
so
it's exactly the same.
Line now.
And there we go. So I'm going to mark that line now.
That second line, that top line, is where the water's
at. That second line, that top line, is where the water's at when I have two balls in there. And I'm going to take them out.
And the water is back down to this. So I want you to have a think about.
And the water is back down to this. So I want you to have a think about what does it mean if the water level is higher.
The amount of water that's being displaced.
The amount of water that's being displaced when I put the balls in is all the way up to this top line.
Okay,
so that is the volume of these two balls.
In the water.
Okay, let's try again. I'm putting the two balls in the water. So the volume of these balls
moves the water up to that top line. That is the water that's being displaced.
Moves the water up to that top line. That is the water that's being displaced.
How much water
so I really want you to understand that how much water that is displaced from when I add my items in is the volume of the object that's going into the water. Another object, I've got in a glass. Now these two, they're identical.
Everything
the
about them is
weight,
identical.
the volume,
so
their height, everything about them is identical.
How much the water displaces now, having a different
how much the water displaces now, having a different
so this
volume,
has
a different object. Okay, so this has a different volume to this because they're two different objects.
The same object, they have the same
if you have
volume.
two of the same objects, they have the same volume. So let's see how much the water is displaced with a different set of identical objects.
Different set.
There we go.
Objects,
I have my
I'm going to mark
different
the line
set of objects, and I'm going to mark the line
of displacement.
So
if the water's being displaced even further.
So if the water's being displaced even further
a different volume.
The container because there's a different volume
so I'm going to take these out again,
of object that's been put into it. So I'm going to take these out again, and my water has dropped back to my original line of where I filled it up. Volume of the object, the more water it displaces. So we know that that's
this where I originally drew
first line is where I
drew on
the container. That's where I filled the container up to. This second line was where the hockey balls
this top line
moved
is
the water to when I put them in.
Then
this top line is the glasses.
The volume of this
so that must mean
is less
the volume of this
than
hockey
the volume
ball
of this glass.
Is
because
less
we know that the second
than the
line
volume of
is
this
the hockey ball,
glass.
so the
because
water
we
only
know
got
that the
displaced
second
a little
line
bit higher,
is the hockey ball, so the water only got displaced a little bit higher. But really, when I put the glasses in, that's pushed the water all the way up. That means the larger the volume of the object, the more water that's going to be displaced.
So this is Tuesday's activity. What you've just watched in the video before this, how I was putting the hockey balls and the glasses into the container to make the water displaced. So you're going to be doing that as an experiment. Now you need 4 different objects. These could be rocks, you could get spoons, small balls, anything that is suitable to get wet. So don't put anything in the water that could get ruined. Okay, so you need to have something suitable. You need to get a towel to put underneath the bucket just in case it overflows, and a marker to mark your water levels on the container. So you can go into your maths folder and click into your Jamboard, and I've got the structure of how you need to label your items on the Jamboard. You label your items from lightest to heaviest. So the lighter the item, you put a number 1, and you go number them 1, 2, 3, 4, and 4 is the heaviest. Okay, so the heavier item will mean the more water will be displaced. So if I was labeling the items I just used, I would have the hockey ball as number 1 because it was the lightest, and the glass would be number 4 because it displaced the most water, which means it has the larger volume. So then you're going to place your objects into the container and mark the changing water levels. And then you need to fill in page 2 of your Jamboard and upload some photos of you completing your experiment. I would love to see them. So for Wednesday, you're going to go to your Maths Wednesday folder and click on the Jamboard. You're going to be doing another experiment. This time, you're going to be guessing how many items will fit into your container without overflowing them. You can write this number into your Jamboard, and then you're going to do the same thing. Place your objects into the container and stop before it overflows. Then you're going to go back to your Jamboard and write the actual number of objects it took to fill your container without it overflowing. And I wonder if you can guess correctly. Can you guess how many objects it's going to take before it overflows? So here I've got a list of the items you need. You need some different objects. Remember to choose items that are suitable to get wet, like rocks or Lego. You need a container again and another towel to sit under your container. For Thursday, you're just going to go to your Jamboard and answer the questions.